Japan. Known for its amorice, sushi conveyor belts and anime, little did you know that a seemingly peaceful country brought about one of the most feared and prominent dogfighters in World War II history, the Mitsubishi A6M Zero. The Mitsubishi A6M Zero, nicknamed Zero, was a revolutionary fighter aircraft that set new standards in aerial combat during the early stages of World War II. Renowned for its exceptional agility, long range and lightweight design, the Zero dominated the skies over the Pacific, outmaneuvering most Allied fighters in dogfights. Its formidable performance in battles like Pearl Harbor and early Pacific campaigns made it a symbol of Japanese air power. However, its lack of pilot protection, vulnerability to fires, and limited engine power eventually became significant weaknesses as more advanced Allied aircraft entered the war, shifting the balance of air superiority. This is Richard Collins, and you're watching Iron Horizon. The Japanese Zero's fuselage was built from extra super duralumin, ESD, an advanced aluminium alloy prized for its lightweight and high strength. Measuring 9.06 meters in length, the fuselage had a streamlined shape designed to reduce drag. The aircraft's exterior was meticulously finished with flush riveting and smooth joints to enhance aerodynamic efficiency, contributing to its high-speed capabilities. The wings of the Zero had a 12-meter wingspan and a total area of 22.44 square meters. These wings were built with multi-spar construction, providing them with both strength and lightness due to the use of duralumin ribs. This robust design gave the wings the structural integrity required for high-speed maneuvers. The wingtips were rounded to improve airflow, reducing drag and enhancing roll rate. Hydraulically controlled split flaps, which increased lift during takeoff and landing, were incorporated without significantly adding drag. The tail section was composed of a narrow vertical stabilizer and a lightweight horizontal stabilizer, both reinforced with internal metal frames. The vertical stabilizer ensured precise directional control, even at high speeds. The horizontal stabilizer, constructed similarly to the wings, provided steady pitch control. The rudder and elevators, fabric covered over metal frames, further reduced the aircraft's weight while maintaining control responsiveness. The landing gear featured retractable, hydraulically operated main gear with oleo-pneumatic shock absorbers, which used oil and air pressure to cushion landings and reduce stress on the aircraft structure. High-strength alloys were used for the landing struts, while rubber tires ensured durability. The system retracted into sealed wells to maintain the plane's aerodynamics. The tail wheel, while non-retractable, was free castering and small, minimizing drag. The Zero's cockpit was topped by a one-piece, bubble-style canopy designed for maximum visibility in all directions. Made from lightweight plexiglass, it provided excellent forward, side, and downward visibility. The manually operated slide mechanism allowed the pilot to enter or exit easily, with emergency egress facilitated by a hinged design. In terms of internal structure, the Zero was small but very efficient. The cockpit of the Japanese Zero was compact, designed to fit a single pilot snugly to reduce drag. It featured essential instruments like an airspeed indicator in kilometers per hour, an altimeter calibrated in meters, a magnetic compass, a fuel gauge in the pilot's direct line of sight, and engine monitors for RPM, oil temperature, and pressure. The pilot controlled the aircraft with a throttled lever for engine power and control column for ailerons and elevators, and rudder pedals for yaw movements. Early models had a thinly padded aluminium seat with no armor, while later models added a 3mm steel plate behind the seat. A basic oxygen system with a regulator supported high-altitude operations. The Zero's fuel system consisted of two main tanks in the wings and fuselage, holding 518 liters of fuel. External drop tanks, each typically carrying 33 liters, extended the range and could be jettisoned when empty. Fuel was delivered to the engine via mechanical pumps. Early models lacked protection for the fuel tanks, but later versions incorporated partially self-sealing tanks to prevent fuel leaks from minor punctures. Powering the Zero was the Nakajima Sake radial engine, Early models used the Sake-12, a 14-cylinder air-cooled engine generating 940 horsepower, while later versions employed the Sake-21, producing 1,130 horsepower. The engine's air-cooled design featured cooling fins around each cylinder. A single-stage supercharger improved high-altitude performance, and an individual exhaust stack system helped expel gases while providing minor thrust. The Zero was equipped with a 3-blade, constant-speed metal propeller, 3.05 meters in diameter. A hydraulic system controlled the propeller pitch to optimize performance across varying speeds and altitudes. This made the Zero incredibly difficult to challenge in a dogfight. The Japanese Zero was equipped with a potent mix of machine guns, cannons, and a bomb rack, providing it with versatile combat capabilities. Mounted symmetrically above the engine cowling were two Type 97 aircraft machine guns, chambered for 7.7mm, 0.03-inch ammunition. These guns were synchronized to fire through the rotating propeller arc, using a synchronization gear to prevent the bullets from striking the blades. The Type 97 had a rate of fire between 600 and 750 rounds per minute, with an effective range of 200 to 400 meters, 656 to 1,312 feet. In terms of muzzle velocity, it was able to reach 730 meters per second, 2,395 feet per second, giving these guns sufficient stopping power for close-range dogfights. On the other hand, the machine guns were gas-operated and belt-fed, cooled by airflow through slots in the engine cowling to ensure consistent firing during extended engagements. In addition to the cowling-mounted machine guns, the Zero was outfitted with two wing-mounted 20mm cannons. Early models were equipped with Type 99 Mark I cannons, while upgraded versions featured the improved Type 99 Mark II. Positioned outside the landing gear in each wing, these cannons were electrically fired. The Type 99 Mark I had a rate of fire of about 490 rounds per minute, while the Mark II, with improvements, fired between 520 and 550 rounds per minute. The effective range of these cannons was roughly 600 to 800 meters, 1,968 to 2,624 feet, allowing the Zero to engage enemy aircraft from longer distances. When comparing the two together, the muzzle velocity for the Mark I was 600 meters per second, 1,968 feet per second, while the Mark II achieved a higher muzzle velocity of 750 meters per second, 2,460 feet per second. Both models were air-cooled, with barrels exposed to the airflow, and were fed by drum magazines. The Zero also had a single bomb rack mounted on the center line beneath the fuselage. Positioned between the landing gear, the bomb release mechanism was electrically operated, providing the pilot with precise control over bomb deployment during ground attack missions. While not a weapon, the Zero's external fuel drop tanks were essential for extending its operational range, particularly during long-distance missions in the Pacific Theater. The aircraft could carry 1 to 2 drop tanks, typically mounted under each wing, with each tank capable of holding 330 liters of fuel. Once the fuel was depleted, the pilot could manually jettison the tank to reduce drag and enhance maneuverability in combat. This versatile armament made the Zero a formidable threat in both air-to-air combat and ground attack roles, combining machine guns, cannons, and bombing capability with its renowned speed and agility. Apart from the effective weaponry, the Japanese Zero was equipped with formidable ammunition that enhanced its effectiveness in both air-to-air combat and ground attack missions. The Type 97 7.7mm machine guns were supplied with 500 rounds per gun. These rounds were typically loaded in mixed belts of armor-piercing, tracer, and incendiary ammunition, giving the Zero versatile firepower. The armor-piercing rounds penetrated light armor, while the incendiary and tracer rounds helped in targeting and igniting fuel tanks or flammable materials. Each 7.7mm bullet weighed between 10 to 12 grams, with muzzle energy ranging from 2,200 to 2,800 joules, depending on the type of round. The Type 97 fired the 7.7 by 56R British cartridge, known as the .303 British, widely available cartridge during the war. This ammunition was well suited for engaging enemy aircraft at close range, effectively combining penetration and fire-starting capabilities. The wing-mounted Type 99 20mm cannons provided the Zero with heavier firepower. Early models used the Type 99 Mark I cannons, which were fed by 60-round drum magazines, while later models employed the Type 99 Mark II, which increased magazine capacity to 100 rounds. These cannons fired a variety of shells, including high explosive (HE), high explosive incendiary (HEI), armor-piercing (AP), and tracer rounds. The HEI rounds were particularly lethal, designed to ignite fuel tanks and inflict severe structural damage on enemy aircraft. The Type 99 Mark I fired 128-gram shells, delivering a muzzle energy of around 28,800 joules. However, the Type 99 Mark II, with its improved muzzle velocity, fired shells with increased energy, reaching approximately 41,000 joules, making it more destructive, especially at long ranges. These cannons gave the Zero the ability to engage heavily armored targets, such as bombers, quickly and effectively. In fact, during the Battle of the Coral Sea in May 1942, the first ever major naval engagement fought entirely by aircraft, Zero fighters used their 20mm Type 99 Mark II cannons to deal significant damage to the US Lexington, an American aircraft carrier. They targeted the ship's flight deck and aircraft using the cannon's high explosive shells, which ripped through the thin armor of American fighter planes, shredding their fuel tanks and causing catastrophic fires. For bombing missions, the Zero could carry a standard 250-kilogram high explosive bomb, often used for anti-ship and ground attack operations. These bombs were typically filled with either TNT or a mix of TNT and RDX, Royal Demolition Explosive, giving them significant explosive power. The bombs could be fitted with either impact fuses, which detonated on contact, or time delay fuses, depending on the mission objectives. Impact fuses were ideal for direct hits on ships or buildings, while time delay fuses could be used to detonate after the bomb had penetrated deeper into a target, maximizing structural damage. One notable part of history this had a major role in was during the Battle of Leyte Gulf. On October 25, 1944, in arguably the biggest naval battle to have ever happened in history, a Japanese Zero plane used kamikaze tactics to sink the USS St. Lo, an American escort carrier. With the bomb affixed beneath its fuselage, the Zero dove steeply towards the ship. In a devastating explosion, the aircraft, along with its powerful bomb, ripped through the deck of the American carrier. The resulting explosion caused massive fires and ultimately led to the ship's sinking, marking the first time a kamikaze attack successfully sank an Allied warship. Behind this glass cannon of a beast lies the sheer brilliance of Japanese engineering, ultimately trading almost all forms of defense for raw attack and speed. When empty, the Japanese Zero weighed 1,680 kilograms, 3,704 pounds, a reflection of its lightweight frame and materials. Fully loaded, its maximum takeoff weight reached 2,410 kilograms, 5,313 pounds, including fuel and the pilot. In terms of flight performance, the Zero reached a top speed of 533 kilometers per hour, 331 miles per hour, at an altitude of 4,500 meters, 14,760 feet. Its climb rate allowed it to ascend to 6,000 meters, 19,685 feet, in just 7 minutes and 27 seconds. And it could operate to a service ceiling of 10,000 meters, 32,810 feet. However, in combat, it was typically flown at lower altitudes for optimal performance. The Zero's impressive range of 1,870 miles, 3,020 kilometers, could be extended to 3,105 miles, 5,000 kilometers, with the addition of drop tanks making it capable of long-range missions. The control surfaces were highly responsive. The ailerons, elevators, and rudders were cable-operated and covered with fabric to save weight, with a metal frame for durability. The large rudder connected to the pedals provided excellent left or right steering, while the ailerons, The small flaps found at the end of each wing offered quick roll adjustments. Hydraulic split flaps, the flaps at the back of the wing that extend or retract, increase lift during takeoff and landing. All these help the pilot maintain level flight with minimal effort. The Zero's hydraulic systems were primarily used to operate the landing gear, flaps, and brakes. An engine-driven hydraulic pump powered these systems, ensuring reliable operation as long as the engine was running. If hydraulic failure occurred, the pilot could manually override the flap system. A small engine-driven generator powered the aircraft's electrical systems, supplying electricity to the instruments, lighting, and radio equipment. This setup ensured that the pilot had consistent access to critical data and communication tools during missions, allowing him to give all of his focus on just gunning down their opponents. As formidable as the Zero was in its prime, it also had severe critical shortcomings. Firstly, the lack of pilot protection was a major issue. Early models had no armor plating, leaving pilots vulnerable to enemy fire in dogfights. The exposed fuel lines also made the engine highly susceptible to fire and engine failure when hit, with no protective armor to mitigate the damage. Secondly, fuel tank vulnerability plagued the Zero throughout its service. Initial models lacked self-sealing fuel tanks, making the aircraft prone to igniting even from small caliber hits. Later models featured partially sealed tanks, but they were insufficient in fully addressing the risk, with fires commonly breaking out in the wings and fuselage where the tanks were located. Thirdly, the fragile airframe further compromised the Zero's survivability. The lightweight extra super duralumin construction saved weight but sacrificed durability, making the plane particularly fragile under the stress of high-speed dives or after sustaining enemy fire. Its multi-spar wing design also proved inadequate, with combat damage often leading to structural failure. Another drawback was the limited engine power. The Nakajima Saki engine, with 940 to 1,130 horsepower, was underpowered compared to Allied fighters like the P-51 Mustang. This reduced the Zero's straight-line speed and performance during high-speed chases. Additionally, the single-stage supercharger limited its high-altitude capabilities, making it less effective above 6,000 meters. Lastly, the Zero's poor high-speed maneuverability was a significant handicap in modern aerial combat. At speeds over 300 miles per hour, the ailerons and elevators became stiff, reducing the aircraft's ability to roll and pitch quickly during high-speed engagements. Its inferior dive speed also left it vulnerable. The Zero struggled to dive steeply, and compressibility issues made it difficult for pilots to pull out of dives without risking damage to the airframe. The Mitsubishi A6M Zero played a crucial role in several major World War II battles, including the attack on Pearl Harbor in 1941, a turning point for the Pacific Theater. On December 7th, during the surprise assault on the US naval base, the Zero provided vital air cover for Japanese bombers and torpedo planes, engaging US aircraft in fierce dogfights. With the Zero's superior maneuverability, Japanese pilots were able to destroy a significant portion of the US Pacific Fleet, drawing the United States into the war. Another important key role in history was at the Battle of Midway. From June 4th to the 7th, 1942, the Zero once again played a key role, escorting bombers and engaging American planes in the air. However, despite its performance, the battle marked a critical defeat for Japan, with the US Navy sinking 4 Japanese aircraft carriers. The Zero's limitations, such as its lack of pilot protection and poor high-speed maneuverability, became more apparent, unable to prevent Japan's first major naval loss. By the end of World War II, the Mitsubishi A6M, once the unrivaled king of the Pacific skies, had become a symbol of Japan's early successes and eventual decline in air superiority. While its exceptional maneuverability and long range were groundbreaking at the start of the conflict, the Zero's design flaws, such as the lack of pilot armor, fuel tank vulnerability, and poor performance at high speeds, became fatal liabilities against more advanced Allied aircraft like the F-6F Hellcat and the P-51 Mustang. As the war progressed, the Zero struggled to compete, outclassed by faster, more heavily armored enemies, marking the end of its dominance in the air. If you liked this video, Like, comment and subscribe to catch more breakdowns of different Allied and Axis planes, along with what made them the best of their time. If you're interested in more World War II engineering marvels, go check out our previous video on the B-17 ball turret. Iron Horizon out.